Hi, Kinesiology 4120. Welcome to our lecture on nutrition, supplementation, and performance-enhancing drugs. So I'm going to kind of go through an overall, all-encompassing discussion on nutrition, what kind of the strength coach role is when it comes to nutrition, and supplementation, and things to avoid with performance-enhancing drugs, so that we understand them a little bit better. At the end of this, please post to the discussion board questions you have about nutrition so that we can discuss them in our lab. All right, let's get going. So first of all, we have to talk first about our macronutrients and micronutrients. So our primary macronutrients are carbohydrates, proteins, and fats. You probably remember these as our primary energy substrates from our bioenergetics lecture. So these are where we can create energy. This is where our metabolic energy comes from. Micronutrients include vitamins and minerals. These facilitate in metabolic reactions, organ function, muscle contraction. These help enzymes work and speed up reactions. We need vitamins and minerals, but we need them in much smaller quantities compared to macronutrients. That's why they're called micronutrients, not because they're less important, but because we need less of them. And then water, we'll talk about it as kind of like the fourth macronutrient. It doesn't allow us to create energy. However, it does make up over 60% of our body. So we need to discuss it also when it comes to hydration. And then mixing water with micronutrients can sometimes be discussed as electrolytes. We'll discuss a little bit more of that also. Okay, so first of all, you've probably heard the saying, you are what you eat. That's kind of what it comes to with protein, but that's not the whole picture. Realistically, you are what you can absorb. So most of that absorption of the food that we take in is broken down in our small intestine and is absorbed in our small intestine, some in our large intestine, depending on the depending on some carbohydrates are absorbed in the large intestine. But most of what we take in is in the small intestine and is facilitated by hormones produced by our pancreas or and other productions within our digestive system. As well as our intestinal lining being able to take in those nutrients. If we have some kind of problem, so maybe we have inflammation in your gut, or you have some kind of disease that is causing your intestinal lining to not function properly, you will not absorb all of what you take in. So it's not all about what you put in your mouth, it's about what your small intestine, your intestines can absorb. Because we can't use it if we can't absorb it. When it comes to how much we should consume, you can look at your the packaging of whatever you're consuming. One of my general guidelines is if it has a nutrition label, it's probably not as nutritious. So when you go and buy vegetables or you go and buy meat from the store, it likely does not have a nutrition label, okay, because it's not processed. Things that are processed will have a nutrition label. We'll get into that a little bit more later. But when it says the percent daily value, that is based on a 2,000 calorie diet, which is not the diet for most athletes that we'll work with. But we can take this as a reference for us. But I want you to pay more attention to the grams of each of these, especially fats, carbohydrates, and protein, as well as the vitamins and minerals, depending on what we're trying to watch. But fat, carbohydrate, and protein are the crucial macronutrients, and we need to watch how much we're consuming and consume the correct proportions of each. Okay. Most of the time, you're not going to be able to easily weigh and track all of your food. As much as would be preferred for your athletes to be able to do that, or you to do that, I do recommend barring any poor relationship with food, if you have a normal or a positive relationship with food or no real feelings towards food, I recommend trying a tracking method for the next 7 to 14 days of your food. I want you to track everything, write it all down. You can use things like MyFitnessPal. You can use a notebook. You can use an Excel spreadsheet. It doesn't really matter, but I think you should try to track your calories and your macronutrients. It is much more difficult than you may think, because most people will actually underestimate the number of calories they consume and the portions that they're consuming, which is sometimes good for your athletes, but general population not as much. But I do recommend using the hand method. So based on your hand, it's proportional to your body size. These are some general recommendations. I'll go with these. Your palm, so the thickness and the size of your palm is somewhere around 3 ounces. So if you have, say, a piece of chicken breast, and you look at that chicken breast, compare it to your palm, if it's the same size as your palm, it's probably around 3 ounces. I recommend at least a minimum of 2 palms per meal of your animal-based protein. 2 cups is 2 open hands. 1 cup is 1 fist. Half a cup is just a cupped hand, rounded off. 1 teaspoon is about your index finger, and a tablespoon is about the size of your entire thumb. So teaspoon, your last digit on your index finger, tablespoon, your thumb. So you can use these as general references. And when we're calculating our calories from what we're taking in, we know that protein and carbohydrate both contain 4 calories per gram of the macronutrient. Fat contains over twice as much at 9 calories per gram of fat, which means that we don't have to consume the same quantity in grams of fat as we do carbohydrates to equal the same amount of calories. Okay, so just make sure you're able to do that math when you're calculating your portion sizes. Okay, I'll get into some more details on that in a little bit. Okay, first of all, we need to understand that carbohydrates, first, are not the devil. For some reason, there was a time period where carbohydrates were awesome, everything, and fat was the devil. And now it seems to have switched to now carbohydrates are the devil and fats are great. So realistically, we need both. Neither is bad. There is no such thing as a bad food. Foods do not have moral inclinations. They're not out there to get you. They don't have malintentions. Same with carbohydrates, same with fats. They're not mean, they're not bad. Carbohydrates are our source of energy, our key source of energy, especially within exercise. So low levels of carbohydrate consumption can limit especially endurance and repeated effort performance within a game or a practice or a training session. So carbohydrates also are digested quicker. So we have certain ones that can be digested very fast, like monosaccharides and disaccharides. These are simple carbohydrates. These are the kind of carbohydrates that we want to consume immediately pre and post training to replenish glycogen stores within the muscle. Glucose, fructose, galactose, I recommend closer to the fructose and galactose portion. They're more complex molecules. Glucose, if it's immediate, like within a training session, yeah. But fructose, that's where we get fructose from fruits. And galactose, you get it from milk. So that's one of the reasons why milk is often prescribed as a post-exercise supplement, sort of, or a post-exercise food recommendation, because it has galactose, which is a simple sugar, as well as high levels of protein and fat that are easily digestible for most people. Disaccharides like sucrose, maltose, and lactose are a little bit more difficult to break down. Sucrose is table sugar. Lactose is another milk sugar. Some people have trouble digesting lactose, so that's where understanding your athletes can play a role. But simple sugars, monosaccharides, great post and immediate pre-exercise carbohydrates, as long as they're in quality sources and not from processed sources. We'll get into that later. Okay. We also have complex carbohydrates. These are the kinds of carbohydrates you should have with your meals. So primarily starches, like grains, legumes, tubers. So examples would be like potato, sweet potato, different types of legumes and grains, depending on how your athlete digests them. I personally struggle with some types of grains, but I'm very good with tubers and legumes, so I try to push those as more of my my complex carbohydrate sources. Fiber is found in fruits, vegetables, and grains that are non-processed. A key there, not processed. So that orange juice that you drink is not a fruit. It does not count as fruit. Your vegetable, your V8, don't count that as your vegetable. You're missing out on a ton of fiber that is a carbohydrate, but it's not a carbohydrate that we can digest and use for energy. These help with things like slowing down stomach emptying, so you feel full longer, as well as it slows how fast your stomach empties into your small intestine, which gives you a longer period of time in which to absorb the nutrients that are running through your small intestine. The faster it goes through your intestines, the less time you have to absorb, especially those micronutrients. So we want to slow down the movement of glucose into the blood after we eat these kinds of foods so that we don't have that giant insulin spike, unless we want that, which we can play around with that. We can talk more about that in lab. But if we're trying to have something like a breakfast, lunch, dinner, we want to shoot for more fiber in those. Insoluble fiber and soluble fiber just depend. Soluble fiber can break down and be. It is soluble within water, so it is a type of fiber, but it's not kind of think of the bulky fiber. Insoluble fiber is not soluble within water, so it helps with us to kind of move through the intestine, so it pushes things through. Think of it as kind of a giant bulldozer that's pushing things out of your large intestine. It helps to prevent constipation, digestive disorders. It helps solidify your poop. Yeah, I said poop in our lecture. It is something that you should pay attention to if your athletes are complaining of bowel movement issues like loose stool. It may be a sign that you're not consuming enough insoluble fiber, and might be something that you should start addressing with them and talking to them about. Next thing we'll talk about is protein, or starting with amino acids. We talked about this with muscle protein synthesis. This is where we get those amino acids from. Our body can formulate conditionally non-essential and non-essential amino acids. So our body can put those together. Doesn't mean that we don't need to consume them, but our body can put them together on its own. However, essential amino acids cannot be produced within our body. There are 9 essential amino acids that we must consume within our diet in order to have proper function. A key one in there is leucine. Leucine has been found to be one of those amino acids that can assist in muscle protein synthesis. So leucine, as long as you're consuming enough leucine, it will benefit your muscle growth. But we need all of them. In animal proteins, so meat, fish, poultry, eggs, dairy, there are all 9 essential amino acids present, because the animal, in that case the animal or the fish or the bird, took in those plants that had multiple different types of amino acids and because their stomach shape and size and function, they can produce essential amino acids from their food, unlike humans. Humans are omnivores. We're meant to consume plants and a variety of animal. If that's not you, if you choose a lifestyle that is not the consumption of animal products in any way, shape, or form, you need to pay attention now to ways to get adequate protein, because our bodies are really complicated in this sense. So if you consume an omnivore diet, which includes animal-based proteins, so meat, fish, eggs, poultry, dairy, you're probably getting all 9 essential amino acids whenever you consume. Soy is often used as a meat substitute because it's the only plant that has all 9 essential amino acids present within the plant. So there's a positive there. That's why soy is used in a lot of meat replacements like tofu. And then there are certain combinations like grains and beans. So things like combining rice and beans, combining whole grain bread and peanut butter, can give you all 9 essential amino acids. However, we won't digest all of them as easily as we digest animal proteins. We digest animal proteins faster and more efficiently than we do plant proteins, because we have a small digestive tract, unlike some rudimentary animals that have multiple stomachs in order to break down the large consumption of different plant-based matter. They're able to get more of those amino acids from the plants that they consume. So the argument that there are animals that are herbivores, they're made to be herbivores. But I have no qualms against someone who chooses not to consume animal proteins. It's just more difficult to consume adequate amounts. You have to consume higher quantities of plant-based products or plant-based food sources in order to get adequate protein amounts, which does come with those added calories. So if you're trying to limit calorie consumption and maintain muscle mass, that diet is probably not the most efficient for you. I also have a hint up here at the top of the screen. So we talked about earlier with those hand-based measurements for your protein. 1 egg, 8 grams of protein. 1 ounce of meat, 8 grams of protein. Half a cup of beans, 8 grams of protein. 8 ounces of milk, 8 grams of protein. 2 tablespoons of peanut butter, 8 grams of protein. So if you're looking simply at the protein, you now have a nice general idea of how much you're consuming. So you can use this. So that means that a palm of animal meat is likely around 20 to 24 grams of protein. 3 eggs, 20 to 24 grams of protein. 8 ounces of milk, about 8 grams. So use that to your advantage when it comes to helping your athletes understand what they can consume that has higher levels of protein, because as we talk about a little bit later, protein is key. Okay, that's why there's arguments over carbohydrates, there's arguments over fats, but nobody argues that we need protein. Okay? If they do, they probably don't understand human function. When it comes to things like branched chain amino acids, hey, you might go to that supplement store and they're like, hey, you need these BCAAs. They're full of BSS. You don't need branched chain amino acids within your workout unless there's only evidence that branched chain amino acids assist in muscle protein synthesis when you are in a protein deficit while training. So if you're doing something like fasted training, or you're not consuming adequate amounts of protein in your diet regularly, they may help you. If you consume adequate amounts of protein, they will not help you, and you're probably wasting your money. So there's very little evidence of their benefits, but it really comes in those who are, maybe they're a physique athlete or bodybuilding athlete, and they're in their cutting phase and they're trying to maintain amount of muscle mass while they're in a calorie deficit and a slight protein deficit. BCAAs are likely beneficial for them sometimes. So unless you just like the flavor of them and you want to consume them because you think it's awesome, go ahead. But evidence says probably don't need them as long as you're eating all of the protein you need in your diet. Because proteins do many different things. They work as enzymes, hormones, antibodies. They help us regulate fluids, create structure like collagen and muscle tissue, not just actin-myosin, but more than that. And they also act as a molecular transport. So our body is really made of proteins and the combination of amino acids. So we need proteins. The ones we often talk about is for muscle protein synthesis. We also need it for collagen synthesis within our connective tissue and our skin. We need the ability to have high levels of immune function and hormone function, enzyme function. Okay, we need protein. Nobody's going to argue that protein is bad. Protein is always something that we need from a quality source. Okay, this does lead into our anabolic hormones reminder. Okay, hopefully you watched our hormone section lecture. Insulin-like growth factor, growth hormone, testosterone, and insulin are all key anabolic hormones or help muscle protein synthesis. Okay, IGF-1 and insulin are proteins. Okay, they're proteins that stimulate protein synthesis. We need protein. When it comes to digestion of protein, there are faster digesting proteins than others. So things like whey protein, which is a byproduct of processing milk, and it's a milk protein. One of the benefits of whey protein and milk protein is that it digests in about 30 minutes. So that's why I say your anabolic window, we can talk all about that. Whey protein is a fast digesting protein compared to solid meat protein, which takes a slightly longer, 90+ minutes for you to digest all of that protein and get it to be usable within your body. So if you're looking for immediate post-workout to have the maximum amount of protein available, fast digestion like whey and milk, awesome for that. Solid meats, a little slower, so maybe consuming your high protein meal an hour or two before your training session, you're still going to have adequate protein within your circulating throughout your body, and you're not going to be at a deficit when your body needs it. That's one of the keys with consuming high protein meals. You have more available. You don't need a whey protein supplement to have your gains or to build muscle mass. It just can be a benefit, especially if you're in between meals. We can talk about the logistics a little bit later. Now let's get into fats. Fats are not the devil, just like carbohydrates. Foods are good. Well, foods aren't necessarily good or bad. Foods are necessary. We have two different types of fatty acids, saturated and unsaturated fatty acids. How you tell them apart: saturated fats, often animal products, and they're solid at room temperature. That does not make them the bad guy, but they are just solid at room temperature. Unsaturated fats, liquid at room temperature. Unsaturated fats can be mono or polyunsaturated. It just depends on their double bond orientation. Okay, you need both. You cannot go without saturated fats. You cannot go without unsaturated fats. You just want to not have too much of each. Okay, you want to keep those proportions optimal. Other fatty acids we need, omega-6s and omega-3s, beneficial with brain function, immune function. Make sure that you're consuming them in adequate amounts and not too much, not too little. But if you're consuming a wide variety of animal-based proteins and a wide variety of food choices, plant food choices, different types of vegetables, multiple different types of plant-based oils, you're probably getting what you need. If not, you may need to supplement. If you're consuming seafood, you're probably getting enough of these. If not, you may need to supplement with some type of omega-3 or omega-6 supplementation, depending on your diet. But that comes with testing and understanding what you're consuming. Because there is this optimum level of each type of food as well as each type of vitamin and mineral. So we have this recommended amount, and then we have this upper limit. Everywhere in there, you're probably good. If you have too little, it's bad. If you have too much, it's bad. We want to be optimal. The body does not work on more is better, less is better. It works on optimum is optimum. Just like training, optimal training is optimal. Too little training, bad result. Too much training, bad result. You can't just add more and think it's going to be better. It's perfect is perfect, optimal is optimal. So let's go into those vitamins and minerals. Humans need 13 vitamins. 4 of them are fat soluble, like vitamin A, D, E, and K. And 9 are water soluble. Fat soluble vitamins do not need to be consumed in the same quantity per meal or quantity per day per week as water soluble vitamins, because they are able to be stored in our adipose tissue and we can pull them out when we need them. This becomes an issue. Things like vitamin K, if you supplement with high levels of vitamin K from unnatural sources like a vitamin supplement, like you took too many of those Flintstone gummies, you could have issues with vitamin A toxicity, where you have too much in your system, it's causing a problem, you're over that level. It's very difficult to get that from food sources. That's one of the other recommendations when it comes to consuming whole foods. You're probably not going to go outside of a realm. You may be deficient if you're not eating a wide enough variety, but I do recommend vary your food sources. Things like vitamin B, especially vitamin B12, is present in animal proteins or animal meats. If you're not consuming animal meats, you may need to find that vitamin B12 from other sources. So wide variety of food choices is always beneficial when it comes to our overall vitamin consumption. If you're low in a vitamin, you don't know unless you do some kind of blood testing. And then you can determine if, yes, I'm low, no, I'm not low. Don't just assume, oh, no, I haven't eaten this food, I'm probably low in this, and then you consume too much. Get blood testing, understand. Okay. So the major ones we have to pay attention to, especially vitamin D. We can produce vitamin D when our skin is exposed to sunlight, but a lot of athletes, especially those who are in winter climates where they don't see a lot of sun, or if you're stuck in your house too long and you're not getting enough sunlight, you may have to supplement with some kind of vitamin D, because there are lots of studies that show that vitamin D consumption and vitamin D levels are associated with injury levels. So having enough vitamin D can help with immune function and healing. Vitamin B helps with metabolic processes, as well as vitamin C with immune and metabolic processes. When it comes to minerals, these are non-organic chemicals, and we need about 17 essential minerals that we have to consume in specific quantities. The key ones that we want to pay attention to are calcium, phosphorus, magnesium, potassium, sodium, iron, zinc, and chromium. These are our primary minerals that we have to consume. There's 17 total, so things like iron is one that we have to focus on a lot in endurance athletes and female athletes. Zinc and magnesium, most people are probably low in, depending on how many vegetables they eat. If you don't eat anything dark, leafy green, you're probably not getting enough. Sodium and calcium and potassium, we know those are all involved in muscle contraction. So if you're low in those specifically, which these come into electrolytes, if you're low in those, there is going to be an issue in your ability to perform muscularly. So we do need these for multiple processes. Make sure that we're consuming adequate amounts. So whole foods, dark leafy greens, colorful vegetables, and if you have to supplement, supplementation. Water and hydration. Loss of water is going to cause a limitation in your ability to perform work. One of my mentors just posted up multiple videos on hydration. I'll link those up as additional resources. But you do have to consume a certain level of electrolytes or some of those minerals with your water to have optimal hydration and keeping those electrolyte balances in place. If we have issues with electrolyte imbalance, it will cause problems when it comes to adequate amounts of muscle contraction. If you have too much water and not enough sodium or not enough electrolytes, you can get what is called hyperhydration, which is also an issue, or is sometimes caused or called by water toxicity. It's really a poor ratio of water to electrolyte, which causes dilution of those electrolytes, which means that they're not able to perform their functions correctly, which can cause the body to shut down and in some cases die. So we do need electrolytes in certain quantities. When it comes to specific athlete nutrition, most of our ATP comes from carbohydrates and fatty acids, not as much from protein. The higher intensity of the work, the more carbohydrates are used. The lower intensity, the more fatty acids are used because they are more efficient. We get more bang for our buck, but carbohydrates are quicker, ready to go. So depending on your athlete, go through your needs analysis. You may have to go through a nutritional needs analysis. One of the keys for aerobic athletes is carbohydrate loading. You may have heard of, I need to carb load if you ran high school cross country, or you did any kind of aerobic event or some kind of endurance event. We need to carb load the night before. Probably not. You actually should be loading your carbohydrates greater than 24 hours before competition, and small doses of simple carbohydrates about an hour and a half to 2 hours prior to aerobic competition is beneficial because one carbohydrate is stored with also 3 to 4 grams of water. So if you're not consuming enough water with that, you're already doing yourself a disservice. So this is how we can top off glycogen stores so that we have optimum amount of free available energy within the working muscle. That being said, do not try to pull the Michael Scott here from The Office and consume a fettuccine Alfredo right before your run because you have to carb load. That's not how it works. Okay, simple carbohydrates day of and right before. Complex carbohydrates likely over a day to multiple days. So that week leading up to competition should likely be higher in carbohydrate, especially depending on your training. If you have glycogen depleting training, you need glycogen replenishing food consumption. Sorry, I'm going a little fast, but we can discuss more on that. The day of the event, just get enough to top off your glycogen stores because sometimes it can cause gastrointestinal distress if you're consuming too much food prior to aerobic competition. Any of you who have ever done a 5K or a mile race, if you consumed too much food beforehand, didn't have enough time for gastric emptying, so getting that food out of your stomach, probably caused some pain and some discomfort, which is going to decrease your performance. So simple carbohydrates, probably don't consume anything within an hour and a half of your competition, just to allow for everything to settle and move on through your intestinal tract. Post-training, you have to replenish your glycogen stores within that 20 to 24 hours. Do your best to consume the food, and it will take about a day to fully replenish glycogen stores. So if you have very hard training the day before competition, very glycogen depleting, you're doing yourself a disservice for your competition the next day. That comes with planning your training. But if we can consume carbohydrate within 2 hours of that competition, we can speed up that process and begin replenishing glycogen so that in case you have maybe multiple competitions over multiple days, so you have preliminary rounds and then you have competition or another competition the next day, you need to be on top of your carbohydrate consumption to speed up this process and improve it. When it comes to resistance training, so this is, you're now working with your athletes in the weight room, glucose is going to be the primary fuel source during resistance training because most work is done anaerobically. protein should be consumed either pre or post. Okay, you just want an adequate amount available for muscle protein synthesis when it is stimulated. So your anabolic window in most adults, not older adults, in most young adults, fit trained athletes, you're going to be stimulating some sort of muscle protein synthesis all day. So as long as you're consuming enough protein, you're going to make it. Consuming it pre and post might help. It will help, especially in older adults, where protein is often not consumed in high enough quantities, and we need more of those hormonal stimulus to get muscle protein synthesis in older adults. So consuming it closer to your exercise session is definitely beneficial for your older clients. But as long as we're getting enough protein, which is 1 gram per pound of body weight or 2.2 grams per kilogram, that is our what we should set as our threshold. That's what we should get. Less is not going to help us as much. More, not shown to help us that much more, but that's kind of our number that we need to hit. It must also be high in leucine. So it's recommended that 0.05 grams of leucine per kilogram of body weight. Most of the time, if you're consuming some kind of whey protein or soy protein or meat, animal protein, you're getting enough leucine. If you're not, that's where you need to start paying attention to what you're consuming. And as well, you need to be consuming protein throughout your day so that you can continue that muscle protein synthesis. As long as we get 2.2 grams per kilogram or 1 gram per pound of body weight of protein per day, you're going to be okay. It's best to space that out in 3 to 5 hours between meals so that you can consume enough in each meal and you're not eating all day. But if you try to do this in 1 or 2 meals, it's going to be extremely difficult and you're likely not going to get enough protein. That comes on the practical side of food consumption. When it comes to supplementation, most supplements are somewhere like a vitamin, a mineral, amino acid, like a protein supplement, an enzyme supplement. Dietary supplements are not legally considered drugs, so they're not regulated like drugs. They're also not considered food and regulated like food. So there can be issues, and sometimes they're not digested in the correct manner because they are processed. They're not whole foods. There can be issues. And just pay attention. Labels can be deceiving. If you see anything that says something like proprietary blend, they don't have to tell you exactly how much of each of those chemicals is within that supplement. So it's kind of a little crapshoot. Supplements are tricky. The supplement industry likes us to think that they are the best. It's going to make or break us. It's not. If you eat whole foods, people have been gaining muscle since before the supplement industry was started. They are going to do it with or without. It all comes down to energy consumption and protein consumption. And some of those supplements, if you have to be regulated by some kind of oversight, like USA Drug or Anti-Doping Administration or the NCAA, you should watch your supplementation because you don't know in some cases if that supplement has a compound that is banned from your competition. So I recommend minimize supplementation. Only supplement with what we know works, which is caffeine, sodium bicarbonate or citrate, nitric oxide, creatine, and beta-alanine. These have all been researched and shown to have improvements within performance. Most often endurance components or endurance performance, but some slightly in anaerobic production also. I did talk a little bit about sodium bicarbonate. Don't just start guzzling sodium bicarbonate. It can work as a buffer within your blood for those hydrogen ions. Small quantities Okay, less is more with baking soda. So small amounts, I'm talking like fingernail amounts, not a whole teaspoon, like a little bit can go a long way. But do experiment with it. It can cause major gastrointestinal distress. Nitric oxide helps with vasodilation, so blood can move at a higher rate. Supplementing with creatine can maximize creatine stores within the muscle, can produce higher levels of anaerobic energy production for slightly longer periods of time. So that can help with training and anaerobic sports. Beta-alanine has been shown some benefits in anaerobic endurance sports as a buffer for that acidity, similar to how bicarbonate works. The jury's still out a little bit on beta-alanine, but in most cases it works. It is the compound that causes some kind of, or in some cases, some tingling sensation or itchy sensation that many people don't enjoy. So if it doesn't work for you, it's not going to work. But things like caffeine, creatine, definitely have been shown to work. There is many research studies out on the effects of these. So we know they work, we know they're safe to an extent. If you have some kind of kidney issue or you have some kind of heart issue, obviously talk to your doctor before you take any kind of supplement. When it comes to performance enhancing drugs, first of all, most are not legal. And if you're caught with production, consumption, purchase, they are controlled substances like most illicit drugs. So pay attention. You should not have them. As well, there are many different forms. There are anabolic steroids, which help to speed up the recovery process and enhance the anabolic reaction within the body, or the creation of, in this case, muscle. Prohormones, which cause, they're hormone precursors, so they help with facilitating anabolic hormone production, as well as supplementing with different hormones like human growth hormone, insulin. Those have been used as anabolic supplements. Consumption of those, if you're going to consume any of these, make sure that you are monitored by a doctor. Do not just go ahead and just start taking all of these things. One hand, most of them are not legal. The other hand, they have some major side effects. There's other things like beta blockers, which can improve your steadiness. These are especially banned in things like shooting sports and accuracy-based sports. Ephedrine, which is a banned thermogenic drug that can cause an increase in heart rate, increase in body temperature. It is one of those things that you've probably heard as like a fat burner. Like ephedra is an example. They're banned. Most of ephedrine products are banned because of the negative cardiovascular effects. There's also EPO, which is erythropoietin, which is a hormone that our body produces that stimulates red blood cell production. If we stimulate more red blood cell production, we can carry more oxygen. This is often used in endurance events like long duration running and cycling. And it is banned in most of those competitions. So let's look at all the side effects. Things like liver toxicity, tumor production, changes in cholesterol, cardiac arrhythmia, reduced sperm count, lower testosterone production, high blood pressure, increased risk of infection from utilizing different needles, depressed immune function, glucose intolerance, masculinization, so an increase in, and there's also there's changes in hormone levels which can cause males to develop more female features, as well as females to produce more male features because of the change in hormone balance, premature closure of bone growth, increased cancer risk. Okay, there's just a lot more that's bad than good. So if you're not being monitored by a doctor, I don't recommend ever touching any of these substances. Okay. When it comes to guidelines, I'm going to go through some of the basic guidelines from the NSCA. If you are performing light activity, you should be consuming 17 to 16 calories per pound. Okay, so that's capital C calories. Kilocalories and capital C calories are the same per pound of body weight. Up to heavy activity, so think aerobic sports or high volume training, about 23 grams or 23 calories per pound. So a 200-pound athlete should be consuming over 4,000 calories. Okay, if they're performing heavy activity. So do the math. Heavy would be most of our major sports that are have an endurance component. Training would fall in most often into the moderate category up to heavy, depending on the type of training. When it comes to specific macronutrients, we want to shoot for, I don't look at it as the percentage protein. It normally falls in this zone. If you get 2 or 1 gram per pound of body weight or 2.2 grams per kilogram of body weight. Normally, we'll take care of that. Filling in the carbohydrates and fats is your second goal. So if you have a 200-pound male athlete, they should be consuming at least 200 grams of protein per day. If you look at how many calories that is 800 calories. We said earlier that our 200-pound athlete should be consuming about 4,000 calories. Do the math. 800 goes into 4,000, falls in this nice, pretty zone. And then we have carbohydrate and fat. If it is a more endurance-based sport or high volumes of training, higher levels of carbohydrates. Lower level or less of your percentage is going to be from fat. As exercise intensity goes down, I recommend just lowering carbohydrate consumption and manipulating the carbohydrates with the type of activity. Okay, so recommendations, carbohydrates should be about 8 to 10 grams per kilogram of body weight, while protein is about 1 gram per pound or 2.2 grams per kilogram. So that's about 22 grams per pound of body weight of carbohydrate and 2.2 grams of protein. And then for water recommendations, recommend about 17 to 20 ounces of water before exercise, as well as during exercise, consuming water and water with electrolytes, all the way through and post exercise. We can talk more about the specifics, but if you lose a pound of body weight after training, you should consume a minimum of 16 ounces of water with electrolytes. Likely you probably need to consume even more because 16 ounces of water was likely lost through sweat plus electrolytes. Consume them both. All right, here are your review questions. I want you to please post on the discussion board your questions about nutrition, because I want to have this discussion because most of your classes likely don't. So let's have this discussion about nutrition and what our role is as a strength and conditioning coach when it comes to nutrition, because your athletes will likely come to you and ask, what should I eat? What should I take as my supplementation? My answer is always whole foods, adequate protein, monitor calories, minimize supplements, no performance enhancing drugs. Those are my rules as a coach, and I recommend you kind of follow those. Whole foods, minimally processed foods are higher quality. Higher quality, more benefit. We can go through all of those in our lab. All right, thanks for watching. I'll see you next week.